All right, this lesson is all about sine and cosine function, their graphs, okay? So we're going to tie a lot of things together here. So first of all, sine and cosine, we've been learning that they can be used as distances. Now we're going to see that if we graph them, they create wave patterns. All right, so first we're going to start with the sine function here. So it says fill in the table of values for f of theta equals sine of theta. To save you time, the decimal places have been given. So this first table is the first half of the unit circle. So just going all the way around, you should be able to, at this point, pretty much by memory, figure out what the sine coordinate is for each of these radian measurements. And remember, the sine uh, of an angle is equal to the y coordinate. Sorry about that. Um, So if I look at 0 radians, well, the y coordinate at 0 radians on my unit circle is 0. And then I can just go all the way around counterclockwise the first half of my unit circle. So if I look at pi over 6, we're at 1/2. If I look at pi over 4, we're at root 2 over 2. Pi over 3 is root 3 over 2. And then we're at 1 at pi over 2. Okay, and then continuing on, if you guys pay attention, we go from 0 to 1, and we go 1 over 2, root 2 over 2, root 3 over 2, 1. Well, then as we continue on into quadrant 2, now we have to come back down off of 1. So this is also going to be root 3 over 2, and then it just goes down the line, just like that. All right, and the decimal places have also been given to you. They've been rounded a little bit, but they've been given to you as a reference. All right, so that's the first half of the circle. And remember, this is counterclockwise quadrant 1 and quadrant 2. So all the y coordinates or all the sine values are positive. I'm going to go ahead and pause the video. You should try and fill out the bottom table here. This is the bottom half of the circle. All right, so I can draw a quick little diagram for us. Let's see if I have a quick set of axes. All right, this red table goes like this, and then you guys are going to fill out this table on the bottom. It's all the bottom half values. All right, go ahead and try it. I will give you the answers in 3, 2, 1. All right, so all of your values should mirror the same thing that's happening up top, except now they're negative. So we left off at 0 at pi radians, so then the next one would be negative 1/2, negative root 2 over 2, negative root 3 over 2, negative 1. And then we got to go back up towards 0. All right, just like that. Now, if we try and graph this function, okay, I'm going to use all of these coordinate points as a reference. So once again, I'm going to color code mine. And we're going to say the x-axis is the angle, the y-axis is our value. So the sine of 0 is 0. So I'm going to start it at 0, 0. Okay, and then I have pi over 6. And this is why you guys were given the decimal values, because you can see this y-axis is in decimal places. Pi over 6, the sine of that is 0.5. And then pi over 4, the sine of that is about 0.707, so just a little bit above 0.7. Pi over 3 is 0.866, so just almost 0.9. And then pi over 2, we're at 1. And then we got to go back down the hill. So at 2 pi over 3, we're also at about 0.866. At 3 pi over 4, we're at 0.707. At 5 pi over 6, we're at 0.5. And then at pi, we're at 0 again. All right, so this is all of the points from my red table filled in. You guys go ahead, fill in the next set from the table that I made blue. And I will give you those points in 3, 2, 1. All right, you should have had something like this plotted on your graph. And then we can very carefully connect all these points. And this makes our sine wave. Okay, now the reason it makes a wave is because as the angle continues around the circle, we start at sine of 0, which is 0. We go up until we hit 1, and then we go back down till we hit 0. Then we continue down till we hit -1. We go back up until we hit 0 again. That makes a wave pattern like this. All right. Now, some characteristics of the graph that I want you guys to pay careful attention to. First, we can talk about where it's increasing and decreasing. So I kind of just did that already, but I'm going to grab my highlighter and I'm going to say, let's say blue for increasing. Actually, let's say green for increasing. Okay, it looks like starting at 0, I increase all the way up to pi over 2. So I am increasing on this interval right here. And then I'm decreasing all the way until I get to until I get to 3 pi over 2, and then I'm increasing again until 2 pi. So I am increasing on the right half of the circle. Okay, let's make red decreasing. It looks like I'm decreasing between pi over 2 and 3 pi over 2. Remember, I'm going down the hill. So on this half of the circle, sine is decreasing. Okay, some other characteristics we want to talk about: concave up and concave down. Remember, concave up is when the graph looks like a valley. It's opening upward, and it looks like I'm doing that from pi to 2 pi. So again, let's say green is up, and then we'll make red down. I'm concave down, or opening downwards, from 0 to pi. So from here to here, something like that. Okay, very good. Now let's flip it over to the back. Let's talk about cosine. So very similar. You should be able to just go ahead and fill in this entire table using your unit circle. Cosine and sine are going to have very similar patterns to them. I'm going to let you guys pause the video and try this, and I will give you the answers in 3, 2, 1. All right, your table should have looked like this. For the top one, we start at 1, where the angle is 0 radians, and we go, as we move counterclockwise around the circle, the x values decrease. So we start at 1 and we go down towards 0 once we hit pi over 2. And then we keep continuing into quadrant 2, where the x coordinates are negative, and we keep going all the way to -1 when the angle is pi radians. So we start high and we go all the way down. And then once we hit that halfway point, now we got to start crawling all the way back up. So we switch gears and we start going up towards 0. And then we keep going once we're into quadrant 4 all the way back up to 1. Okay, so a little different than sine. It looks like sine starts low, goes towards 1, and then back down towards 0. And then we go down to -1 and then back up to 0. So we have 0, 1, 0, -1, 0. That's kind of the pattern we follow. For cosine, we start at the very top. We go 1 down to 0, -1, back up to 0, and then 1 again. All right, so for this one, you guys can go ahead and plot those points. And once again, I will pause the video, or sorry, you can pause the video, and I will give you the answers in 3, 2, 1. All right, you should have had something plotted like this. And I can go ahead and connect all those points. And we start to see our cosine wave. Something like that. All right, now let's see. We can see that, first of all, we've only graphed one period of each wave, okay? Both for sine and for cosine. Oops, there we go. So for sine, we graphed one period, and for cosine, we graphed one period. And if you notice, they both start at 0, but they look a little different. In fact, they are shifted off by each other by exactly pi over 2 radians, which we'll talk about in the next lesson, actually. All right. For now, it's just important that you know what these graphs look like and that they are wave patterns. So let's wrap up these notes by talking about the increasing and decreasing intervals for cosine and then the concavity of cosine. Okay, so for increasing, decreasing, it looks like if we start at 0, we are decreasing all the way until we get to pi. All right. So for the decreasing, remember I made that red. From 0 to pi, we are decreasing. And then we are increasing from pi all the way back to the start of the circle up to 2 pi. All right, now concavity. Concavity is a little tricky because there's these weird half hills going on here. So be really careful. Even though you don't see the rest of the hill, this little part right here from 1 to pi over 2, this is concave down. Okay? Or sorry, not from 1, from x equals 0 to pi over 2, my bad. Okay, so we are concave down from 0 to pi over 2. And then it looks like we're concave up until we hit 3 pi over 2. And then we continue to be concave down for the rest of the circle. So we pick it back up right here and finish it. Okay, and then we are concave up between pi over 2 and 3 pi over 2. So along this interval here. Okay, now what I want you guys to pay attention to is what we highlighted. So the sine and the cosine should just be flipped, right? Wherever sine and cosine are concave up and concave down, that's where cosine is increasing and decreasing. And then vice versa. Wherever sine is increasing and decreasing, that's where cosine is, cosine is the oppositely concave. So it is concave up where sine is decreasing, and it is concave down where sine is increasing. Okay, so there's some patterns there that we can kind of see. For now, that's it for this lesson. We will make more connections between sine and cosine in the next video.